All right, here we go. Part 2 of geometric sequences, and we are dealing with partial sums and infinite sums in this video. All right, so continued. Okay, so geometric sequences. All right, so we already looked at, we looked at this last problem. Okay, so maybe it gave some of you guys a headache. Don't be afraid of it. Okay. 8.3 continued. So now we're going to take a look at the sums. When we looked at arithmetic sequences, we looked at partial sums, the sum of the first 5 terms, the sum of the first 10 terms. And then we looked at, the sum of the first 100 terms, which hopefully you are not, you're not writing 100 terms out and then adding them on a calculator. Okay, so whenever you see high numbers like that, there's a formula for it. Okay, if you have to find the sum of the first 3 terms, fine. Just find the first 3 terms and then add them together. But if they're saying find the sum of the first 100 terms, there's going to be a formula. Okay, so partial sums. For geometric sequences, defined by an, which equals to a times r to the n minus 1, right? The nth partial sum and remember like if they say the 10th partial sum, then that's just the sum of the first 10 terms. They say the 50th partial sum, then that's the sum of the first 50 terms. If they say the 4th partial sum, then that's just the sum of the first 4 terms, right? So the nth partial sum. So when usually it's denoted like this. So if they're saying the nth partial sum, then they're saying to add the first n terms, whatever they are in the sequence, and we know that the terms are represented like this, right? All the way up to the nth term. Okay. And of course, r is not 1. Okay, so the nth partial sum, that sum is actually given by this following formula. So instead of gathering all the terms that you need to add together and then adding them on a calculator, instead of doing it that way, you could actually just find the sum by using this formula. A, which is the first term, times 1 minus the common ratio to the nth power. Let me write that over. That's an n, r to the n, all over 1 minus r. Okay, so this is a nice partial sum formula that you have here for geometric sequences. Okay, so if they ask you to find the sum of the first 100 terms, use this formula. Don't write down all 100 terms and try to add them on a calculator. Use this 100 terms, n is 100. Make sure you know your first term. Make sure you know your common ratio. Okay, all right. So let's take a look at an example. Find the following. Find the following partial sum of a geometric sequence and suppose it's 1 plus 4 plus 16 plus all the way up to 4,096. All right, so something that's not super easy, like I could have given you the first 5 terms and said find the sum of the first 5 terms, right? Okay, so what makes this a little tricky is the fact that over here, we don't know what term that is. Is that the 5th term? Is it the 100th term? We don't know, right? So we need to know what term this is. And the reason why we need to know that is because we want to know what n is. So, i.e., we need n. And we only know what n is if we know what term this is. If this is the 100th term, then we know that n is 100. Okay? All right, so what do we know? Let's see. We know a is 1. We know r is 4 over 1, which is just 4. And therefore, we know the nth formula. Nth formula is a times r to the n minus 1. Okay, so we know all of that, right? We also know this is the nth term. We just don't know what n is. So I'm going to take this 4,096 and I'm going to replace an with it. Okay. So 4,096 equals 1 times 4 to the n minus 1. Okay. And I can solve for n now. N is what I need, right? I needed to know what term this is because I needed to know what n is. I have an equation here. I can solve for n. Okay, so 4,096 equals 4 to the n minus 1. I'm going to take the log of both sides. 4,096 equals the log of 4 to the n minus 1. Doing this allows me to bring the exponent down to the front. So log of 4,096 equals to bring the exponent down, divide both sides by log 4. So this side gets divided by log 4 so that I have n minus 1 by itself now, and now add 1 to both sides to get the n by itself. And I get log 4,096 over log 4 plus 1 equals n. Punching that into the calculator, you could have done it earlier, I guess. Like I said, I like to do as much of it by hand as possible. So because using the calculator kind of breaks my flow. Okay, so I know what n is. So then now I can use that Sn formula. Sn equals, let's go back and look at it. Sn equals your first term times all of this. Okay, let's go ahead and write that. All right, so n is 7. So we want to know the sum of the first 7 terms. So that's going to be a. Is a 1? I think it was. A is 1, yes. 1 times 1 minus, what was r? R is 4. 1 minus 4 to the 7th over 1 minus 4. Okay. And when you plug this all in, you should get 5,461. Okay. So the sum of the first 7 terms is 5,461. All right. Let's take a look at summation notation. So whenever we're doing sums, we can always use summation notation so that we don't have to write the problem out like this. Okay. So let's do that. Summation notation. All right, so just like in arithmetic sequence when we were using summation, same idea. So let's find the sum. And suppose it's represented like this. K equals 1 to 6. So again, that means find the sum of the first 6 terms. The first term, second term, third term, fourth term, fifth term, all the way up to the 6th term. And this is your formula to find each term. But I don't need to find all 6 terms and then add them up with a calculator. Okay? Because I can use the SN formula, right? SN formula is A times 1 minus R to the N over 1 minus R. We want to use this. Okay? We want to use this. All right, so this is, and here they're asking us to find the sum of the first 6 terms. Okay, I'll give you some more stuff. A equals 7. R equals negative 2/3. Okay, and N is 6. That's where you can find all of your pieces of information you need in order to use this formula. Okay. All right, so the sum of our first 6 terms, which is what this is asking us to find, is equal to A, which is 7, times 1 minus R to the N, which is 6, all over 1 minus R. Okay. And when you punch this in, we get 931 over 243. I'm not sure how WebAssign will take it. If it takes it as a fraction, great. If it prefers a decimal, then use decimal. Okay. Okay. So again, you can use the SN formula, but you do need to analyze this and get your A, get your R, and get your N. Okay. A, R, N. And plug them in. Okay. Okay. Series. So that's just a fancy term for the sum of the terms in a sequence. Series is the sum of the terms in a sequence. You could have a finite series. Finite series is a sum of a select amount, a finite amount. Finite, a finite set, okay, of terms. in a sequence. Okay. So that would be like A1 plus A2 plus A3 plus, but then you stop, right? Finite. Infinite series is the sum of an infinite number of terms in the sequence. Okay. And so you would be adding first term, second term, third term, and you would just keep on going. You wouldn't stop the way you stop here. Okay. Finite, you stop. Infinite, you keep going. Okay. And so you might be like, oh, well, how does that happen? How do you keep adding an infinite number of terms and get an answer? Well, it happens with certain geometric sequences. Okay, and we'll see when. When does that happen? Okay, so the sum, we already know this one. We already know how to find the sum of a finite series. Okay, finite sequence. We use this, right? This is what you use. So if you need to find the sum of the first 100 terms, that's finite. If you need to find the sum of the first 1 million terms, that's finite. You would use this formula. Okay, so let's focus on infinite right now. Okay, so sum of an infinite geometric series. And like I said, it only happens in certain cases. So if your common ratio, the absolute value of your common ratio, because sometimes your common ratio could be negative, right? Okay, so if the absolute value of your common ratio is less than 1, then the infinite geometric series converges and has the sum S. Sometimes there's a notation like this with infinite, okay? Sometimes it doesn't. Okay, so S equals A over 1 minus R. Okay? So again, you are able to find the sum of this infinite series here, geometric, only if your common ratio, the absolute value of your common ratio, is less than 1. Okay? Then you're able to find the sum and you use it. You find the sum by using this. Okay? If the absolute value of R is greater than or equal to 1, the series is what we call it diverges. Okay? Diverges, and there you can't find the sum using this formula. Okay. All right, let's take a look. Determine if the geometric series converges or diverges And again, it converges or diverges depending on R. So determine if the geometric series converges or diverges. If it converges, find the sum. Okay, so let's take a look at this first example. Suppose I have this 2 plus 2 over 5 plus 2 over 25 plus 2 over 125 plus, and it goes on forever. Okay. All right, so first of all, we need to determine whether or not it converges or diverges. And it says up here that all depends on the absolute value of R. If the absolute value of R is less than 1, then it converges. If it's greater than or equal to 1, then it diverges. All right, so R is 2/5 divided by 2. 2/5 times the reciprocal, and we get 1/5. Okay, so R equals 1/5, right? So then based on this here, the absolute value of R is less than 1, therefore it converges. And because it converges, we are able to find the sum. S equals to, let's go back up here. This is the formula I will be using. So turns out that the absolute value of R is less than 1, therefore it converges. And so I can calculate the sum using this. A over 1 minus R. So let's use A over 1 minus R to find the sum. So the sum is A, which you can look up here, is 2 over 1 minus R, which is 1 over 5. Okay? And then if you work this out, I'm going to go ahead and multiply everything by 5. So I get 10 there, I get 5 there, and it cancels out there. So I get 10 over 4, and I get 5 over 2. So my sum is 5 over 2. Okay? If I look at this example, suppose I have this one, 1 plus 7 over 5 plus 7 over 5 squared plus 7 over 5 cubed plus it goes on forever. All right, so then R is 7 over 5 divided by 1, which is 7 over 5. If I reduce this or change this to rewrite this as a mixed number, this is 2 and 2/5. So absolute value of R is greater than or equal to 1. Therefore, it diverges. I cannot find the sum. Okay, so there's no sum. Okay, all right, because it says so here. This is where it says it. If the absolute value of R is greater than or equal to 1, 2 and 2/5 is greater than or equal to 1, the series diverges. Okay, and there's no sum. So it's greater than 2 and 2/5 is greater than or equal to 1, therefore it diverges. There is no sum. All right, okay, so that is it. We are done. If you have any questions, make sure you text me or email me. I will see you on the flip side.